Hello everyone, good morning. Hello, guys, can you hear me? Guys, can you hear me? Is there any issue with the connectivity?
Yes, we can hear you.
Okay, thank you. Okay. Okay, so this is what it. So today we are going to see the image processing thing, guys. Colored images.
Hello, Ashish. Good morning.
Good morning. Good morning. Let me share the screen. Okay. Okay. So today we are going to see the image processing session, guys. This is one of the demanding sector in AI and machine learning. So it is basically part of deep learning. Okay, and this type of task is basically the data for this kind of tasks are images and videos. Okay, like the data we have in CSV file or data frame we're creating, then we're dividing to X train, Y train, like that. Similar thing, but here the data are present in form of images. Okay, and image and video itself, that is kind of a data. Okay, and this is also a vast amount of data. It is not simple or some rows and columns. Every image is kind of you can consider as one kind of data frame. Okay, and for this kind of task you need GPUs. Okay, like the not CPUs. With CPUs this task will be tedious and it will take so much time. Okay, so for this kind of image processing task you need GPUs, and I'll tell you how you can use the GPUs. In Collab also they are providing free GPUs to deal with this image processing or image detection tasks. You just need to switch here. If you see my screen is visible to you guys.
Yeah, Ashish, it is.
So if you see here in the Google Colab, once the RAM and disk space is allocated to you, you can see here the RAM size and the disk space size. Here, this is normal CPU server. To make it to GPU, you have to click to this change run type, and here you have to select either GPU or TPU. Okay, and this GPUs are actually cost associated things. So in Colab you will find certain amount of free GPU usage. Okay, not free for everything, but for learning purpose this will be enough. Okay, the Google Colab GPUs. So Google Colab, in Kaggle platform also you will get free GPUs. So basically this type of task is deep learning computer vision. It is called computer vision because like we are seeing the pictures and we are deciding or creating the model based on that pictures or videos. So many ways it is getting used. I'm also working with some projects with computer vision tasks and all, but those are later stage. Before that, you need to understand the basics of this kind of task. First of all, as I said, the data for this kind of task is image, right? And you need to understand how image is being read through Google Colab, how the image is interpreted to the model. Okay, those things we need to understand here. And I can see today 11 people only joined. Okay, we'll start. It's 9:06. We'll start. So first of all, what is pixel? I hope everyone aware about a pixel. Pixel is the short form of what? The picture, the shortest element of a picture, right? Is the basic of a digital image. It is a small square-shaped element color that when what happened? Okay, when someone talks about the resolution of a computer monitor or TV screen, they are referring to the number of pixels. Okay, that means the more the number of pixels, the higher the quality of the picture will be. Okay, now this is smallest unit of picture. Now how computer process and understand the images with this pixel information. Now this is suppose this is a picture of 8. Okay, this is a picture of 8, and if you see here the small boxes from here to here, let me show you through this one. Can you see in the first picture, can you see the small squares in the 8
Yeah.
images? Let me check, just a minute. So this parts, okay, this parts is a combination of this kind of things, that this is called pixel. Okay, and computer is going to understand this pixel wise data. Okay guys, so let's try to understand what it is. These small boxes are called pixels. We often use them, use the term the dimension of the image is x cross y. Now what is x cross y? It is same thing that you do with the data frame. df.shape. df.shape will, what information it will give you? The rows and column information. The image also this same kind of information. But there you are dealing with only one data frame. Here one picture itself is one kind of data frame, one single picture. Now how this is happening? Suppose you are going to detect or classify, you are going to build a classification model, which will, the famous example dog and cat, right? So that means you have to give number of dogs pictures and cat pictures to the model, so that model will understand, okay, this is the dog picture, this is the cat picture. So every picture itself is the data set. Okay, that's why we need higher processing units, or faster processing units, because every picture itself is kind of a data set, and you can train 20,000 30,000 pictures like that. Okay, so you can imagine now, that's why we need the CPUs. If you will try, it will take days to train. So this x cross y is specific to one single picture, that is telling you the number of rows and columns. Okay, and each of these pixel is denoted as the numerical value, and these numbers are called pixel values. Okay, that means this single square or the pixel that we are referring, that should be, the computer is not seeing any color or something, as we already discussed these things. Machine is only machine is going to understand numbers only, because the calculation, for calculation purpose, it is going to consider the numbers. These pixel values denote the intensity of the pixels. The number associated with each pixel denotes the intensity of the pixel. For a grayscale means black and white image, we have pixel values ranging from 0 to 255. Okay guys, 0 to 255 should be, so every pixel will contain one number between 0 to 255. The smaller numbers closer to 0 represent the darker shade, while the larger number closer to 255 represents the lighter or the white shade. Are you getting what is happening here, guys? If you go to this one, here you can see the darkers are small numbers, but when there is a white number, it is close to 255. Okay, so this is what it is saying. If in a black and white image, you are representing some pixel values close to 0, that is the black part. If the number is closer to 255, that is the white part. Okay, this is how the computer will understand. Now this picture, see, computer, so you passed this image to your machine will interpret this as this, like this, a single picture. Okay, so machine is not going to understand the colors and all, it will understand the numbers associated with it. It will understand, okay, so those pixels whose values are close to 255, those are higher intensity colors, or we can say white colors. This is how computer understands a picture. Any query here? Okay. Let's see what we have next. Okay, so every image in a computer is saved in this form where you have matrix of numbers. This is the matrix of numbers, and this matrix is also known as a channel. So this kind of terminologies, okay, channel, okay, matrix, pixel, you are going to encounter this. So this channel is important because when we have color image, this channel is going to play a crucial role. Okay, we'll see. So as of now, for black and white image, to summarize, every pixel and their value will decide the intensity of the color, whether bright or dark, and each picture is considered as one matrix, and we can also call them as a channel. Okay, now let's see what we have next. So if you see here, what is the shape of this matrix as per the above image? That is the number of rows and the number of columns. So I think the number of rows here is 24 and the number of columns here is 16. So what is the shape of the image here? 24 cross 16. Okay, so it is a 24 cross 16 matrix. Understood, right, guys? Simple one, right? Now let's come to the color images. This is all about black and white images. Now how color images getting interpreted by the machine and how machine understand a color image. This is also one important factor, because in real life you are going to deal with color images only, unless there is a requirement for grayscale or black and white image. Okay, a color model. And one more thing, while dealing with the color images, there are few models, base models, what you are going to consider. It varies from companies to companies or the work environment that you are working. That means some use RGB model, some use HSL model, HSV. Okay, we'll see those things. Okay, So basically, there are a couple of models based on which you are going to define your color images. Okay, one of them is called RGB color model. A color model converts colors into numbers that a computer can process. And in real life also, what happened, every color that we are seeing, that is the combination of three basic colors. So this is called RGB color model: red, green and blue color. So that means some portion of red, if you are going to mix with some portion of green and some portion with blue, that is going to generate some specific color for you. And every color that around you that you are seeing, that can be converted, or that can be a thought of combination of these three basic colors, that is RGB: red, green, blue. Okay, now for example, if you see here, this is a purple color, right? The first is a purple color. Now how purple color will be formed? 167. So consider this is the proportion of the colors of in terms of R, then green, then blue, red, green and blue. So so this purple color can be generated by considering 167 of red, 83 of blue and 151 of green. Okay, if you I think I told okay, 167 red, 83 of green and 151 of blue. Okay, if you combine these three colors with this much proportion, a new color, that is purple color, will be generated. Now can you see what is the black image proportion here? Black image is 0, 0, 0. That means we have seen this in the grayscale image also, right? When the value is close to 0, the grayscale image will be dark, right? Or black. And if it is white, then it is close to 255. So now every proportion, every color from RGB will range from 0 to 255. Okay, now if you consider 255 of each RGB, that is going to give you white color. Okay, almost all colors can be generated from the three primary colors, that is red, green and blue. We can say that each colored image is composed of these three colors, three channels: red, green and blue. So this is a color image, dog's image. Now this is a combination of these three images. What is that? Red, green and blue. Okay, now this red is one matrix, green is one matrix, this blue image is one matrix. That means matrices of numbers. So if you combine these matrices of numbers, it doesn't mean that you are adding them. You are just stacking on top of another. Okay, that means what is happening, guys? So to visualize this picture, you have to look through three different matrices. Okay, one is red, then you keep another matrix here. What is the blue? Then another matrix here. Okay, that is green. And if you look from this side, okay, by stacking on top of each other these three colors, you are going to see the final color. Okay, it's not like adding the matrices. You can, you can consider stacking of matrices. Now in grayscale we discussed this matrix is called what? One channel, right? So we have now three matrices. That means how many channels we are talking about? Three channels. So that means a colored picture is a combination of three channels or three matrices. So tell me, if this image has 20 rows and 20 rows and 30 columns. Okay, what is the shape of this image now? 20 rows and 30 columns. What is the shape of the image now?
30 cross 20.
Yeah, 20 cross 30. But this is a combination of three channels. So there is another dimensions is getting added to it. This color picture is not a 2D, two-dimensional structure now. This is a three-dimensional structure now. Okay. And another dimension is number of channels. So if you see a color picture,
And also, just like about to that, you have mentioned mentioned X cross Y, right? So if it is X cross Y, then it's supposed to be 30-60, right? Sorry, it's 30-20, right?
so rows into columns, rows. So I said this is the total number of rows, right? In
Okay.
this direction, rows, in this direction, Y. Just to give you some example. So rows cross, this is the
Column.
row, this is the column, this
Column.
is
Okay.
the channel.
Okay. Okay.
Okay, so if you were combining three pictures with red channel, green channel, blue channel, that's why another dimensionality will be added to it, that is 20 cross 30 cross 3. Okay, this is the shape of the color image every time. That's why it is called three channel red, green, blue. Okay, now let's see other types of models we have. Model in the sense color model. Now this is also one example of this parrot picture, and if you convert their respective RGB component, so here guys, this maybe seems easier thing, but in industry standard point of view, this is kind of a tedious task. Like this kind of task is performed while detecting logo. Recently, not recently, a few months back, I was doing one project with a USA company where their ultimate job is to detect the logos from the product, because in the market there are what we can say, duplicate logos are being circulated. So their company was detecting the logos and in the original format, and if there is a duplicate logo they want to identify that, so they were building a model to identify duplicate logos. Okay, so those kind of stuff, okay, is a kind of a complex task. One of the component of their task is to extract the color components. This is called, so if this image will be given to you, your task is to find out the RGB component of this image. Okay, that means if there is the original picture, you have to collect the component information or the feature information from the color images, and there is a duplicate picture there also, you will try to extract them, and then you can compare how similar these two images are in terms of their components. Also some other factors are there which I'm not, so basically this called feature extractions of an image. Feature means color feature. What is the red color feature, green color feature, and blue color feature? So even if this kind of task also can be performed through machine learning also. So what you can do, you take an image, you extract the color component and other component and create a data frame out of it. Suppose this is parrot picture 1, P1. You create one data frame for parrot picture 1 where you have a data, one row will be parrot picture 1. Here the columns are red color component, green color component, blue color components. There is other components also you can store here. Like that, you can extract the information from one image, then you can feed this to a machine learning model, and you can classify it as a supervised learning algorithm.
How to extract the details, sir? We are having that image. How to extract the red, green, blue, that kind of
Yeah,
details?
so that is some advanced topic which I'm not going to discuss right now. But yeah, using the code. Okay, in Python there is certain libraries, right? Like we have statistics and all. So those libraries are there. Using those libraries, you can extract the information. Okay, but here this is just a small part. I'm because I saw this picture and this RGB, that's why this is the small part. So many other things are there. Okay, so many other things, because if you don't extract all the information like this RGB, you won't be able to classify that image. But the point is your understanding of this picture. Okay, how you can interpret this picture and how you can utilize it. Okay, now let's see some other color models here. Okay, let me read this thing because these are the important points I mentioned. In grayscale images, each pixel represents the intensity of only one color. In other words, it has one channel. Agree? This that we discussed. Wherein in color images, we have 3 channels. Okay, standard digital camera will have 3 channels. In this case, we have 3D matrix. We have one matrix for one channel, but in this case, we'll have 3 matrices stack onto each other. That's why it is a three-dimensional structure. So the dimensionality will be suppose 700 rows and 700 columns. So this we have seen, right? Okay, so a first matrix will be red, but that means the first channel will be red, second channel will be green, right? And in every channel, okay guys, I forgot to tell you this one. Suppose you extracted the red channel and you got some numbers. What does that number symbolize, or pointing out what that number means for you? Suppose red channel matrix. So this is a combination of 3 matrices: R matrix, G matrix, and B matrix. In R matrix, you have some numbers, certain rows and columns. There you have some numbers. What those numbers represent? In grayscale, that is the intensity of dark and white. Can you think of something? So this is the intensity of red color. Suppose in 1 pixel of R matrix, suppose in the R matrix, you have columns and rows, right? In one column, it is mentioned 200. What does that 200 means? That 200 means the intensity of, because this is R channel, the intensity of R color, red color. So how, so if you see here how this pixel will be formed, it will be this pixel plus this pixel plus this pixel. Intensity of red color, intensity of green color here, intensity of blue color here. Okay, once you combine these 3 intensities, you are seeing this final intensity as this color. So in each matrix, there is some number, and each number represents the intensity of that particular color in that matrix. Okay, let's see, just a minute.
Yeah, Ashish, so that means if we keep the blue and green colors to 0, then we'll get the red color, right?
Correct. So that means you don't have any other channels, only red channel.
Yeah, okay.
Okay, so in general, each pixel in color image has 3 numbers, 0 to 255 associated with it. These numbers represent the intensity of red, green, and blue color in that particular pixel. So consider this one. So how this is going to be formed? I have drawn this picture previously, but not this much clarity. So RGB, you can see. So here the intensity of R channel is more. Okay, green channel and blue channel are a bit less. Okay, so this is which model, guys? RGB model. Red, green, blue. I told you there are a couple of models that it varies from companies to companies, or platform to platform, which model they are using, whether RGB and any other model. So in any other model, there is another model called HSL or HSV color model. Okay, HSL, HSV.
Excuse me, sir. Here we are okay. That concept I was clear. RGB we have used in a single picture. We have some other shades we have in a single cells, that in that matrix we have one single square. In that single square we have combination of RGB. And how to know that what is the proportion of R, G, and B. And if we able to know the details, how to get the details means, then only we can able to clarify about the image, right?
So you mean to say how to know it is 141 or 35, 31?
Yes.
So you need not to know that right now.
Okay.
You just need to see because you are not seeing this, computer is seeing this. Okay, you are seeing the color picture. Computer is seeing like this. There is the R channel, G channel, and B channel. But good question.
Before that, you told that one picture they will give you have to verify which is very which is a true logo or it would be fraudulent, right? Somewhat. For that, we need to know the proportion, and then only we can able to find out. Is it right?
Yeah, correct. So for that, you need to understand bit more concepts. Let's jump to that concept first. That is just the application I told you, that you can utilize this concept in this kind of applications. Okay, but for that you have to write some complex code to extract the details from the images. Let's not
Okay,
jump there.
normally we have one picture. How do
Normally?
we know the normally any picture that parrot picture or somewhat any other picture, we have one picture. How do we if we want to combine or somewhat get we need to put one color in that picture, means we have to know the proportions. That's the thing I asked.
No. You need not to know the proportions unless you are solving some problem like I described, logo detection.
Okay, if we want to create one color, means randomly we can give 0 to 25, 255.
So if you have one color, okay, you can call the shape property like you're calling from data frame. That will give you the row number of rows and number of columns and number of channels.
Okay.
That information you just need. You don't need any proportion of colors. Okay, unless you are solving this kind of task that I described, but that is the latter stage, not now. Before that, you need to understand few concepts. Okay, so as of now,
excuse me, Ashish, everything lies in between 0 and 255, like that, you know.
correct.
Everything. So just as someone asked, if at one point we are seeing only red means, then the B and G, I mean blue and green will be, that won't be 0, no? I mean 0 means black, right? That would come like.
So if you remember just before I was showing you the purple color. Okay,
yes,
purple color means what? That is the combination. Some proportion of red plus green plus blue, right?
Yes.
So consider this one. Suppose this pixel red proportion is 141, and here 35 from green and 31 from blue.
Yeah.
Now if you, so as I told, every color is a combination of these three. So if we'll combine these three, that will form one color.
Correct. Yeah.
That color will be this part. Okay, you are going to see here as a human being, it is your eye. Okay, you are seeing this combination as one color. That is the formation of 141, 35, 31. So if it is only red, then only red color intensity will be there.
Okay.
And blue will not be there. Okay.
So there not be there means no numbers will be mentioned, but
0. That means how you are forming red color. As I formed purple color by mixing of this plus this. How you are forming red color? This is means 255 plus, if there is no other color, then 0, then 0.
But what I'm asking is 255 is black only and red lies in between.
That is a very good question. That is for grayscale image. Okay. As I told you here, these numbers are the intensity of respective color channel.
Correct. Yeah, that I got. Yes, that point I got. So red only, if I'm saying red only means only red means it will be 255 or something in between that, just like
no. Okay, I got your question. Suppose consider this channel, okay, red channel. Here 155, 145 means how deep red it is.
Correct.
Okay, 255 means the deeper red. Okay, 0 means lighter red.
Okay,
the intensity of that color.
Okay. So for each case, it is 0 and 255 only. I mean the lighter one and the dark one. Okay.
Right?
Got it.
0 to 255 describes the intensity of that particular color. Suppose we are talking about G here. Here 200 means deeper green.
Got it.
Okay, 0 means lighter green.
Lighter
so how these combinations, that depends on the intensity of each color code. Good question. Right. So I hope everyone got that, guys. Okay, please let me know. So this is how you are going to understand RGB model. Another model is there, that is called HSL and HSV. Like RGB, so 3 components, but here not RGB. Here they mention hue, saturation, and lightness. Lightness for HSL and value for HSV. So before that, let me show you how does this look like. HSL color model. See, this is what so before this, we are considering one color image as a combination of red, green, and blue, right? But that is RGB model. If you are going to use HSL model or HSV model, for that the combination will vary. Like concept is same, but the theoretical part is bit different. Here, instead of red, green, and blue, you consider 3 parameters, that is hue, saturation, and lightness. Now here, this is the color model. Here, hue means the angle. So as in RGB, we have 3 components, red, green, and blue. Here we have component like this. Okay. And here that means which angle. Lightness, saturation means which color, and lightness means how dark or how light it is. So every color can be combination of hue, H, S, and L also. If you combine RGB and you get a new picture like this, you can combine this hue, saturation, and lightness to get a new picture. So which model to use, that varies from platform to platform, that you need to understand. Okay. So let's see what is in terms of this hue, saturation model. So 2 models, HSL and HSV. Color models are alternative ways of representing colors based on their hue, saturation, and lightness or value. They are widely used in computer graphics, image editing software, and color selection tools. Hue represents the dominant wavelength of a color and is often described as the color itself. It is measured in degrees on a color wheel. So this is what we are seeing. This is called a color wheel. In the color wheel, hue is the what? The measured in degrees on a color wheel ranging from 0 to 360. In both HSL and HSV, the hue value determines the base color, such as red, green, and blue, etc. For example, a hue of 0 degree represents red, 120 degree represents green, 240 degree represents blue. So this is the color wheel we have. Which color to select, that depends on the angle based on the hue value. Okay, as I said, like if you are considering HSL or HSV model, 0 degree from the color wheel means you are considering red color. Okay, 120 degree, if you'll go 120 degree of this wheel, then you are going to find blue color. Sorry, green color. 240 degrees, blue color. Now this is to find out the basic color.
Sorry to interrupt you. So from the 0 degree represents 0 to 120 will represent red, right? Okay.
Okay. Now saturation. Saturation refers to the intensity or purity of the color. That suppose you found 10 degree. Now 10 degree will be what? Representing something around red color, maybe darker red or lighter red, whatever it may be. Now that intensity of that color will be defined with saturation value. It indicates how much gray color is mixed with the hue. A saturation value of 100% means the color is fully saturated with no gray added. That means pure. While a saturation value of 0% represents a completely desaturated color, appearing as shades of gray. Higher saturation value result in vivid and vibrant colors, while lower values produce more muted or what is that? Pastel tones. Now hue means what? Saturation means what? Did you understand this one?
Yeah, hue is an angle.
Which will be your base color. Now, if you will compare this with RGB, what is the 3 matrix have? We have each number is the intensity of that respective color. Same thing is happening here. From the hue, you are selecting which channel, right? Whether red, green, or blue. In the saturation, you are mentioning what? The purity of the color. That means how pure, if you are considering red, whether there is any gray mixed with that red or not. What is then lightness? So the third component in this model, for HSL, it is lightness. For HSV, it is value. So in the HSL model, lightness represents the amount of white or black mixed with the color. That means the brightness, guys. Okay. If you try to correlate this with the brightness of something that we're increasing in the image, right? That is the lightness represents amount of white or black mixed with the color. The lightness value of 0% indicates black, 50% represents original color, 100% represents white. So, any questions, or is it making sense? Although not, I'm not a color expert.
Ashish, can you please, go to the saturation once again, because the lightness is clear. That's saturation.
So here, saturation means what? Purity of a color. How much gray? What is gray? What is gray color?
It's kind of
Black and white.
Not. See, guys, a saturation value of 100 means the color is fully saturated with no gray added to it. What does that mean? Can you try to think? So in three angles we are seeing. First, we are seeing which color. Then we are seeing the purity of color. What do we mean by purity of color?
like how good the color is. Like no other colors should be added into it.
So if I'm talking about a green color here, if I say this is a pure green and this is not pure green, so what does that mean?
The value should be 255 in it, and then the value is little less in the second one.
We are adding another color with the green color.
Correct. So that means no other color. How pure green is. Now, if you will add, if you create a, if you take a pure green, okay, and inside that you add some other color, the color will be different than in that case. Are you see? So, okay, let me show you the wheel here. I think from the wheel you will understand. Just a minute. See, hue is the angle here. Can you see this color? Let me show something bigger picture here. Now the hue value clear. Hue value means what?
Angle of color, and it is a base color.
Okay. Now can you see saturation? What is saturation defining here in here? This. So how pure that color is. Whether faded green or lighter green or pure green, darker green. Different kinds of greens are there, right? Suppose you are considering about a particular color. So what is the darker green and lighter green? How the darker green and lighter green you can distinguish as a human? So that specification will be defined with saturation. How saturated green is it? Whether it is a pure green color or something else mixed with it, so that it is a lighter green now. Are you getting? So green colors, I think we are not sure about the term, like different colors, and not for me also. So different kind of pinks or like other colors are there, right? Lighter pink, deeper pink. So that kind of stuff are there, right? So that is your saturation, which type of color and how intense or dense it is. That is your saturation. Lightness is what? You change the lightness or brightness in your colors, in a picture. What does that mean? That means you are adding light to it, right? White light, or whether you are increasing the white light or decreasing the white light. That is the lightness. Or still it is not clear to you, Dinesh?
Yeah, Ashish, now I can understand like that saturation. Yeah.
Okay, great. So eventually, so this was not in your curriculum actually. So, but I thought, because I work with this kind of stuff, no. So these are the basic things you need to understand, okay? Because RGB is not the only model that people are using. People are using these models also, but the concept is same, okay? It is a combination of 3 dimensions, okay? And each dimension is representing the final color of what you are going to see at the last, every dimension. Okay, so for example, here pure red will be 0 degree in hue, saturation will be 100%, lightness will be 50%, and if you are using HSV, then the value will be 100%. That is pure red. This is how in HSL or HSV model you define red color. Okay, for example, yeah.
That lightness of the value is, we have known that HSV, HSL, what is that?
No, if you are using HSL model, then lightness, see, hue and saturation in common in both HSL and HSV. Here HSL means hue, S means saturation. Okay, HSL means hue, saturation, lightness. HSV means hue, saturation, value.
And value means?
Value means you are using HSV model.
Okay. HS, okay. Not lightness here, we have used.
Correct. So if you are using HSV model, then lightness you are not using. You are using a hue value, saturation value, and the final value. That value HSV.
Okay.
So here the example based on 2 models. Okay, HSV model and HSL model. In each model, how red color is going to be interpreted. That is what the example is all about. Light blue, hue will be 210 degree, saturation will be 50%, lightness will be 75%. If you are using HSL model, if you are using HSV model, then value will be also 75% for lighter blue. So like this, every color is now combination of 3 components like RGB.
So in HSV, there is no lightness, only the component is value in that. There is no
The third
lightness.
component is value. The third component is value.
Okay.
And one more thing, while doing with real world problems, you can convert from one model to another because your libraries. So in Python, there is a popular library called OpenCV. Okay, OpenCV is the must having skills if you are going for a computer vision engineer role, CV engineer. Okay, you have to deal with some deep learning libraries like TensorFlow, Keras, PyTorch, and OpenCV. If you are familiar with these modules, then you can apply for the CV engineering role. Okay, there those libraries, based on your requirement, you can switch from one model to another, like from RGB to HSV. Because sometimes a different environment uses different model to identify one image, but you can always convert one image in terms of another model. If you are using RGB model, you can utilize also the HSV model to know or to identify the image. That also you can do. There are popular methods in there which you can call, and it will convert from one model to another. Okay, and one more thing. Okay, let me see what we have next. So let me give a conclusion here. What is the final summary here? Okay, have we left anything? By manipulating the values of hue, saturation, and lightness or value, you can create various color variations, shades, and the tints with the HSV. And okay, this is Okay, so that means by changing these three components, you can create new colors. Okay, conclusion. Computers can see an image as a matrix. Grayscale images have one channel. Thus, we can represent grayscale image in the 2D matrix, that black and white image, where each element represents the intensity of brightness in that particular pixel. Remember, 0 means black and 255 means white. Grayscale images have one channel, where color images have three channels, RGB or HSV. We can represent color images in the 3D matrix, where the depth will be 3. See guys, these terms are important. Depth means the third dimensions or the number of channels. Usually, the dimensions of RGB colored images are in the form of NM3. NM3 means number of rows, columns, and the channel, where N is the number of pixels across the height, M would be the number of pixels across the width, and 3 representing the number of channels. In this case, we have 3 channels, that is RGB. Are you getting height and width of the image? Which one it is saying? So see guys, these are very important things if you are dealing with this one. So this is the height. So N means this information. In data frame, this is the row information, isn't it? In width means column information. Okay. Listen. So this is simple. You can understand. It's not a problem. Now let's go to process this data. So in our data frame, how we pre-process the data, guys? What is the pre-processing steps we do? We'll go for normal data frame kind of data.
We need to collect the data, store the data, and then we have process that.
But what the pre-processing steps we followed? Encoding
values.
Correct. And sorry, what is the second thing you told?
Handling null value, missing values, and encoding.
Correct. And what else? Correct. 2 things correct. Still we do some other things, right?
Outlier detection.
Outlier detection. Okay. Still one left. So meaningful data transformation we saw yesterday, right? What we did with meaningful data transformation? Normalization and standardization. This is the main thing, right? Scaling, right? So scaling is also important. Okay. So like this, we need to do, processing, pixel-wise processing also, because this is not an image to the machine. This is a data to the machine, and machine is seeing as seeing this images as numbers and combination of matrices. But we have to pre-process the pixel values also, like how we did with the data frame data. And why we did that? It will, first of all, it will keep every number in a certain range, so that the manipulation will be easier. Also, if the number is small, the calculation that is going to happen inside the model is also going to be easier, isn't it? The calculation of a larger number, obviously it will take more time, right? So processing pixel values is the pre-processing steps you need to do before going to train these pictures with the model. Pixel values are often unsigned integers in the range between 0 to 255. Although these pixel values can be presented directly to the neural network. Okay, what is neural network? This is deep learning stuff, guys. Okay, deep learning. So basically, these pictures are going to used by the neural network models, complex models, in their raw format. This can result in challenges during modeling, such as in the slower than expected training of the model. Instead, there can be a great benefit in preparing the image pixel values prior to modeling, such as simply scaling pixel values from 0 to 1. Now, how to do it from 0 to 1? Normalization. So guys, if you are taking one column, how we are normalizing that column?
Max will scalar.
Max mean scalar. That means that every point minus mean divided by x minus x mean. So if we'll do this, every point in that column is between 0 to 1 range. Same thing we are going to do here also. So that after pre-processing, what we mean by 0, what we mean by 1? Suppose I normalize this pixel values from 0 to 255 range, I brought it to 0 to 1 range. Now what means 0, what means 1? 0 means darker.
0 value and 1 means the maximum 255 value.
Correct. So that means 1 will be lighter or white color. 0 will be dark color.
Yeah.
Okay, let's see how. So 3 techniques usually people uses, that is normalized pixel values, centralized pixel values, and standardized pixel values. Like we have in our standardization and normalization. Here also we have normalization, standardization, and centralization. Now each task depends on, I've made the list also when to use which task. Let's first see what it is or how to do it. Okay, in a picture. There we have that library, right? Scikit-learn and pre-process, then min, max scalar or standard scalar, you will do it. But how to do it in the picture? To understand that, first we'll go with one picture. It is a horse picture actually. Okay, I loaded it also. Okay, now let me first show you the picture. Then, okay, the fun part starts from here. Okay, so I'll talk about this libraries and all. Let me first verify whether this picture is visible or not. Okay, so this one I took from Google just a Google picture, and we are going to use this picture. So suppose this is a picture, and how to deal with these pictures, guys? I load this picture here, okay, in my Google Colab. If you are using Jupyter Notebook also, you can load this to your working directory. Okay, and this is how you can see it. Now, in computer vision or image processing task, 2 main libraries you can use. One is Pillow, that is PIL. One is OpenCV, that I told you, right? CV2, OpenCV. Vast, 2 popular and vast library, guys. If you are planning to make your career in computer vision, you have to go through these libraries. Again, this is also a course, okay, like a long course. So if you recollect, initially I told you this all are in the starting point where you are starting. From here, there is a lot of opportunities you can select. Okay, now to deal with the pictures, there is a library called PIL, that is Pillow. Okay, either you can use a Pillow or you can use OpenCV. Here I am using Pillow library. From PIL, I'm inputting image. So this what I'm taking here image, this is going to help me to interact with the pictures. And from NumPy, I'm importing some array function. We'll see why I'm doing it. First of all, how to load the image? You call this image function, then open image.open. That's all. Image.open, then the path of that image. Okay, and if you'll try to call this image variable here, you will get the picture. We'll do this also with OpenCV, but after a few times, down in the cell. Okay, but here, can you see this picture? This is the original picture. Now, how to know about, like we have the concept of data frame, right? Data frame.info, data frame.describe, those things, right? Similarly, here also you can, select something. What is that? This is called image.format. Let's see what this value is giving us. I'm just commenting the picture part now. Can you see image.format is giving me what? Which format of image it is? JPEG or PNG? Okay. Image.mode will give me what? The model that I am using, or the model that this picture is using. Which model? that is RGB. Image.size, what is it is giving you? 960, 600. 960 is the what? Height or width?
Height.
Okay, let me show you the picture. So if you are getting confused also what is the height and width also, still you can identify from the picture. So what is the value of we are seeing 960 or something? What is that?
960, 600.
960, 600. Now looking at this picture, tell me which part is larger, width or height?
Height.
With the height.
I think, do I need to zoom out a bit?
Yes, Ashish.
So how to zoom out? Can't do.
Control and then the minus.
Control, then the lower key.
Yeah,
or
or
the
else you
minus
can
key.
press control and then scroll down with your scroller.
I think it is not working for me. Okay, no worries. So can you see here? I think the height is more than the width, isn't it? So yeah, guys, the height is more than the width. Okay. So in that case, what is the first element it is showing to us? 960 and 600. So this first argument is your height, okay, and second argument is the width. And using OpenCV, okay guys, OpenCV, you have to import CV2. This library is called CV2. Now if you want to use this in your Jupyter notebook, you have to install this library using pip install, guys, or else it will not work. And these are the larger libraries. It is going to occupy some space in your laptop. Okay, so that's why to deal with this kind of images and all, you need a good processing laptop. Okay, if you it will make, or else it will make your system bit slow. So using CV2. So what is the difference between Pillow and CV2 here? Can you tell me how we are reading an images? In Pillow, we are using image.open. This image belongs to Pillow library. In CV2, we are using cv2.imread. Okay, so these two things you need to consider if you are dealing with both CV2 and your Pillow. Now here, if you will see in CV2, what is the image shape? 600, 963. Can you see now? Here the width is at first in OpenCV. I'm just showing you the comparison between these two libraries. Very popular two libraries, okay, Pillow and CV2. So here in Pillow, the height information is showing first, where it in CV2 the width information is showing first. And what is this 3?
The channel.
That means if you see some image shape is this one, you can blindly say it is a color image. And if it is a black and white image, then these 3 will not be there. Only one channel will be there. And to answer your question, Divya, if you ask like how to know the proportions, so these libraries have some predefined functions, which if you call it, then it will tell you which proportion of red it has, which proportion of blue it has. Like that, it will tell you. You need not to worry about it. Just call that function and library, and it will tell you what is the part of red, blue, and green in that image.
Yeah, okay, sir.
But usually we don't need this unless we are developing a new model or training a new model with this data. But yeah, we can do that. And day by day, okay, I have not shown you the documentation. You are going to like it. This is a vast documentation, OpenCV. Those who want to pursue this, okay, you can, okay, go to this OpenCV official documentation. Here from the introduction to the tutorials, they have given step-by-step approach. Okay, so many things are there, so many. Even if they are adding it day by day, because this deep learning thing is growing enormously these days. So if you want to learn about this OpenCV or Pillow, this official documentation has some tutorials and how to deal with, even if I have not completed all of them, which is in my list also. So whenever I'm getting some free time, I'm going through this documentation. Okay. Now, neural networks process inputs using small weight values, and inputs with larger integer values can disrupt or slow down the learning process. Okay, as it is a good practice to normalize the pixel value so that each pixel value has a range between 0 to 1. This can be achieved by dividing all pixel value by the largest pixel value, that is 255. So guys, why I have to divide this with 255 to normalize? What is the normalization formula?
Max minus min. So here min is 0. So 255 minus 0 would be 255.
Right. So x minus x mean. So here ranges of pixel is between 0 to 255. What is the mean value then? 0. So xi minus 0 divided by 255 minus 0. So that means what? If we'll divide every pixel with 255, that means you are normalizing that pixel. That's what it is saying. This can be achieved by dividing all pixel values by the largest pixel value, that is 255. This is clear, right? This is performed across all channels, regardless of the actual range of pixel values that are present in the image. Okay, let's try to play with it. Okay, image size. Now guys, let me show you something. Image size, that is the width and height. We are not talking about this. Can you see? I am converting the image to an array. Okay, now how this looks like. Okay, so first of all, let me show you pixels.shape will be working or not. See the app. So this pixel variable containing what? The array of numbers. This array of numbers coming from where? Where it came? From the picture. So that means I took a picture, I converted them to the respective numbers, and I stored them in an array. Now, how many arrays are here? Or what is the shape of the array? This array contains what? 600 rows, 960 columns, and 3 channels. Did you get how I convert the picture to the numbers using as array function from NumPy? Okay, and this is what it looks like. So that means this is my picture. When I read my picture, this is my picture, but the dimensions, it will be difficult for you to interpret here, because this is a 3D array, isn't it? This is a 3D array. This is not a 2D array we are seeing. You can see here, this is one dimension, this is one dimensions. Okay, so we have 3 dimensions. That's why the pixel.shape is what? 900, 600 cross 3. Okay, now tell me how to access the first channel from here. Or tell me what will pixel 1 will give me? Which part? Array manipulation.
The second part, x into y part.
What does this 0, 1 means? So if this is my pixel shape, where it has 600 rows, 960 columns, and 3 channel, What this will give me?
The first row.
First row of
This
each
3-dimensional
channel.
first row of each channel, yes.
That's why if I press
That's
save here, 963. This 3 means from each channel it is considering the
first row.
what is the pixel mean? How to calculate the mean value of the pixel? You just need to call the mean function, right? And what is this line? What I'm accessing here from my image?
all the rows from the first column and second column. And
See, this is a 3-dimensional thing. Okay. So how many commas you will get here? 2 commas. The first commas left hand side is the row
Rows.
information. That means how many rows I'm accessing?
1 row, 1 column, all the
One column, all the channels. Correct. So this will be like this. If I'll give the shape here, what will be the shape here? Okay, so like this, you can play with it. We'll also see. Okay. So what you can do, as we convert this picture to array, you can convert the array to picture also. So you can, to understand it more detail, you can play with this array, take few columns or few rows, then plot the picture and see which part you are getting. In this way, you will understand the numbers behind the pictures.
excuse me, sir.
Okay.
Here that column 1, that we have 3 columns. That column 1, first row, first column, and here the third part, what we have retrieved, the channels.
Huh. Correct. The channel information.
Okay. But it here it shows 71, 103, 90, 19.
So if I'll extract only first channel, what I will do? So if I want to extract the first channel information,
0 only we have to do.
this is what you need to do. That means all the rows, all the columns, and the first channel, that is red channel. This is also you can access each channel details.
Okay.
Now this is making more sense, right? Let's not talk about this one. This is making more sense.
Yes, sir.
So
And
whenever we were not giving any values on the semicolon, it'll gives the every rows and columns in the matrix, right? As we do in slicing.
Correct.
Okay.
Now this will be confusing you because here we are considering only one small component. Here this example you will understand more. All the rows, all the columns, and the first channel. That means the red channel. And these values are the intensity of which color?
Red color.
Red color. That means where there is larger number, the intensity of red color is larger there.
Yeah, I understood, sir. But here I am understood the 71 is from the first row and one column from the 103, that is the column value. 90, the channel value I have not understood. What is this?
No, I'll delete this one. Don't understand. This is not going to help you out. This is going to help you out.
Yeah, Ashish, I think in the previous one that what she was asking, those 3 values belongs to RGB, red, green, and blue.
So
And
this
I mean
one,
the values of the first pixel, RGB values.
yes. So just a minute, guys. So you are talking about this one, right? This result 71, 103, then 90, right? So see, how it is. Okay, 71 is coming from where? The row
yes.
information. That is this one. Okay. What is the 103?
That column value.
Not from here.
It's not the
because-
column value, it is the blue value, I think, in the first pixel.
Is it? Just a minute. This one is the, just a minute, guys. If we'll see the shape here, I'm getting confused here.
Yeah, it's the
Okay.
first value is the red value, blue value, the green value in the first.
Okay. So the first pixels, red, blue, and green. So the problem is here, this is a three-dimensional data, no? So the imagining this pixel in mind is a bit difficult here. If you'll do like this, you'll get confused, isn't it? Because this is just one matrix only. One is from red, one is from blue, one is from green. Just one pixel it is, where just one square we are defining here.
Okay, if we give that and that after the 20-second cell pixels column 1 we have give 0 means it will give the red color, 1 means it will give the green, and 2 means it will be give blue, right?
Correct.
And then if we give that after that we can see the numbers what it will shows.
This one.
For everything, for 0 and 1 and 2, if so means we will see the numbers, and then we can easily know what it shows.
Right. So 0 means the first channel, that is row,
Red.
column, and 3 we have, right? Channel, right? So 0 means the first channel, right? 1 means the second channel, 2 means the third channel, like that.
Yes.
And this is the red intensity, this is the blue green intensity.
Yeah, okay. We have seen the 71 is there, 103 is there. If we give a pixel for colon 2 means we will get that blue also, and that it shows. We have clarified it. Yes, now it's clear.
Now it's clear, right? I'm yeah, Silpa, what you are saying?
Yeah, I'm saying the first value of this would be 90. Yeah. So that pixel colon 1 colon 2 and colon 1
without seeing this it is confusing. Without seeing this it's confusing. Now it's clear.
All the three.
Correct. So here pixel 1 1, and here also it is taking, I think, 1 only. Okay, no.
Then it will only give the red value.
Red value, correct. So this, if you will mention, this will give you the
RGB.
Yeah, all three values, correct. So 71 is from the first channel, so the top left corner pixel, right?
Yes.
Or in original pictures, this means what? If I'll do like this means the top left corner pixel of the original picture. What is the value there? 71 from first channel, 103 from the second channel, and 90 from the third channel. Are you getting now?
But Ashish, when it comes to array, the indexing will start from 0, right? So how can we access with a 1 in there?
That is how 3D you need to access this. That's why we are getting confused, because it's a 3D structure. 2D it will not get confused. So here if I'll do, can you see what it is doing? From every channel, it is taking the first two. So 71, 103,
and 90.
Okay, 71, 103. The second one, 71, 103.
Then the
92, right? This one. This is how it is going. Okay, so this is how you need to interpret this one, guys. See, 71, 103, 90. That is the top left corner. Okay, 71, 103, 92. 71, 103, 92. Okay, so like this we are going. Now this is 3D, no? That's why we're getting confused. But not necessary. We need not to understand like this. Okay, you just need to understand how to extract each channel information. That is enough. So how to extract each channel information? This one, like this.
Yeah.
Okay, so this much is enough, guys. You need not to understand that slicing, because this is just a small part of the image. If we'll deep dive into more into it, 3D, that's why it is, you know, getting confused. Now what we are doing here, so we are at normalizing things, right guys? We are normalizing the images. So how to normalize the image? So first of all, let's load the image. Okay, and here I am converting this image to the array that we saw just above it. Now what I am doing here, I am just mentioning the data type of those pixels and the minimum and maximum value of the pixels. Okay, and what I'm doing, I'm converting this to float 32. Why I'm converting this to float 32? So that I can, you know, divide 255.0. Why I'm dividing? Because for normalization, this is what we need to do, right? Isn't it? Now if we'll do it, this is the data type. This is the picture data type. Okay, that's why if we don't convert this to float, this operation will give you error, because the data type is what? Integer 8. So these things are getting stored in u integer 8. So this data type belongs to what? Picture data type. Okay, and before we normalize, this is the maximum value and minimum value. After normalizations, the maximum value and minimum value will be 0 and 1. You understood this code now? Now let's see how this looks like. One more thing, guys. Here I told you, right? You convert the picture to array. Then from array also you can convert to picture. How to convert? See, image from array, pixels, you convert this as float, right? You need to convert it again to unit 8, integer 8. Okay, then only it will be back to the pictures data type. So did you understand? From the picture, we converted to array. Okay, and then we converted to float. So when it is picture, what is the data type? This one. Okay, to do the mathematical operation, we convert this to float, then we did the operation. But to show the image back again you have to convert this from array to this original data type. Okay, and this is how this looks like. This is a totally black image. Now can you tell me why this is a totally black image?
The zeros and zeros means it will be black.
Darker. But see, maybe for the human eye we're not able to interpret it, but the machine understand that this is the picture and this is the value. Okay, and every time you are doing this, you are creating this kind of image in the background. But for us it is not making sense, but for machine it will make sense. So by doing it, what is the benefit we are going to get? The processing will be faster. Why? Because we change the range. Initially the numbers were from 0 to 255. Now it is closer to 0 and 1. So this is how a normalized image looks like. So there is predefined library in Python where while feeding to the model, you have to normalize it. Okay, then only your model performance will be better. This is a basic step and interview question also. Why we do normalization or anything like this, and where we do it. So once you advance through the course, you will get to know. But I think deep learning is not there, but I recommend you guys, after completing this course, please go for deep learning as well. Do one project in deep learning also in your portfolio. Anything, either NLP or computer vision or any kind of neural.
I'm just confused here. We are converting 0 to 1 from the range of 0 to 255. We are converting that 0 to 1. For 0 to 1 means it will be always dark only, right? We
But
can't able to get that real image.
so that's what I said you, like it is not for us. This is not for us to see. This is for the machine. Before training, you have to do this. Before feeding these images for training purpose, you have to normalize it.
Okay, if we do so means after train the data, somewhat what we do before, we need to get some image. That is the purpose of normalizing this image. And that time, how come it will give the color image? We are giving that 0 to 1 range image. How that 0 to 1 range image will give the color image?
So okay, that is a good question actually. So you mean to say we are having these images and we are normalizing it and making it a black and feeding to the machine. Now how the machine will give us back to the color images?
Yes.
Right. So see, the machine is not going to give us any image. The machine's job is to classify the image.
Okay.
So if you have a dog image and cat image, the machine, so you will train the machine, okay? The machine will tell you in the future, if will pass any image, it will pre-process like this. And based on that, it will tell you, this is a cat image, this is a dog image. It is not going to show you any image.
So it will not show the image means for what purpose we are doing this image
Classification.
normalization.
Classification. So suppose you have 50 dogs image, 50 cats image. You train the model this type of black image, 50 black image of cat, 50 dog image of cat. Okay. So it is not black image. For your understanding, I am saying it is a black image. Okay. That means next time when you will feed a cat image, the model will tell you this is a cat image. Next time you feed to the model a dog image, the model will tell you this is a the classifying.
Categorization. We are giving some image. It will tell you. It will tell us whether it is cat or dog through those training images.
Correct. Right.
Okay.
Right.
And before that pixels, we have that we have divided the pixels divided by 255. Whether it takes the value what we have seen before that 90, 103, 71. That numbers it takes and divided by 255, right?
Correct. Every pixel value, correct. And it will be there for each channel also. So every channel we have some numbers between 0 to 255. It will do that for every channel also.
Okay.
So, and also to answer your question, I think this one will be beneficial. Normalization is used to rescale the pixel value of an image to specific range, typically between 0 to 1. It is beneficial when absolute values of pixel intensity is not important. That means the classification problem. There the absolute values are not important. Only the category, whether cat or dog, that is important, right? But their relative values or ratios are significant. Normalization helps to enhance the contrast and bring the pixel value within a specific range. It is commonly used in various image processing tasks such as feature extractions, pattern recognitions, machine learning algorithm that requires inputs in a specific range. Feature extraction and pattern recognitions. These are two broader problem in computer vision. Okay, so when you are going for this kind of stuff, feature extraction or pattern recognitions, you usually follow normalizations because there the pixel value is not important. Okay, so this is normalization. Let me show you what is center pixel values. Now, a popular data preparation techniques for image data is to subtract the mean value from the pixel value. This approach is called centering. So what it is saying, guys, if you recollect so suppose this is x-axis and y-axis. Okay. Now, what we mean by centering? So suppose this is a distribution and this is the mean value. Now tell me, if I will subtract every point from this mean value, what is the changes will be done to my distribution? How the distribution will vary? So this is the distribution. Okay. So each value I will subtract from the mean. What will happen?
The distribution will reduce and then
The
it'll
distribution will
yeah,
shift. The
yeah,
distribution will shift,
shift to left
and
side.
it will be like this here. Okay, if we'll subtract each point from the mean value, this graph will come to the origin as the mean. It will shift from here to here. This is called centering. Centering. And same thing we are going to do with this picture thing also. Okay, let me show you how we are doing it. So first of all, we are loading the image, converting to the float type. Let me converting to array and then to float type. Then we are calculating the mean using pixel.mean. Okay, now before we are doing the centering, let's print the mean and the max and mean value. Do the centering, that means every pixel value will be subtracted from the mean. Okay, let me show you the result out of it. Now can you see, initially the mean was 111. Okay, minimum value was 0, maximum value is 255. We calculate the mean as 2 into 10 to the power minus 6. Now we subtracted each pixel value from the mean. What is the new mean and max value now? And what is the mean now? The new mean is, can I say the new mean is around 0?
Close to 0.
Close to 0, right? And the pixel values also got changed. Now here it is negative and positive, right? What does that mean? That means this type of thing that I draw, right? So here
Is around 0 somewhere. We have left of 0 and right of 0.
so this is 0 to 255. Okay, when I subtract each point from the mean, then what happened? The distribution come here, right? Now the mean is 0 and the values were this side, it is now coming to the negative side. That's why you are getting negative values as well here. So in this distribution, this side is negative, isn't it, guys? So this value will come under negative and few value will come under positive. So this is what you are doing with centering. Let me charge my laptop actually once again. So did you understand this concept of centering, what we are doing, or what is happening if we'll subtract this so with the mean value?
But why are we doing centering actually?
So that is a good question. So to answer that, again, I will take you back to that. Just a minute, let me clear these things. Centralization. It is also known as mean subtractions, involves subtracting the mean value from each pixel in the image. This technique is used to remove the global intensity mean from the image, resulting in a centered distribution around 0. Centralization helps to eliminate the overall brightness variation or illumination difference in an image. It is often used as pre-processing steps in tasks like object detections, object recognitions, where the background or the illumination conditions may vary. What is object detection? Anyone knows here? Object detection and recognition. So it is a broader topic, guys. Okay.
Object detection, we generally like get on those captcha images that identify the blocks where car is there or something like that.
Correct, correct. Object detection means, suppose you have been given one image where there is a cat, there is a dog. Okay. Now, by giving that image, you have to tell me where the cat, where is the dog. Okay, so to understand this one, let me first show you after centering how this pixel looks like. Okay, just a minute. So same concept, guys. You convert from unit 82 array, then you need to convert it back to see the image. Let me show you the image. See, this is how it looks like. If we'll do the centering. Now, what will
So
happen?
this all pixel processing things we're doing because the system will automatically save this data, and then whenever we were giving the another photos of a horse or a dog, it'll say that okay, this is a horse or this is a dog with the previous 50 pictures that we have trained it, right?
Correct, correct. Now, what I read actually in the centering part here, see, this technique is used to remove the global intensity mean from the image, resulting in the centralization helps to eliminate the overall whiteness, variations or illuminations difference in an image. That means if you see here, the background and everything got changed. Only the object is highlighted properly. So this is what you need in an object detection task. Your object is to detect a horse, right? So you don't need any other information here, the background information and all the stuff, right? So by doing centralizations, and if you are following object detection tasks, their centralization will help because it will highlight only the object part. Rest everything, it will change the value. Change the value in the sense like it is making it small, right? Isn't it? Small numbers so that the processing. So why we are doing all this stuff? Because my processing speed will be faster. And I will reduce the unnecessary part. If I'm going for object detections, I don't need the background information. I just need the information about the object, because this is where the model will understand, okay, this is the image and there is the object here. And these values are very less or close to 0 or not necessary. So that the next time, if you will pass this horse image, original colored horse image, it will be easy for the machine to classify or detect the horse rather than going for the background images.
But in
So,
this case, Ashish, like the main object, for example, the horse, the intensity, the colors of the horse were more than the background only. That is why we are able to detect using
but that is a very good question. As I told you guys, this is a broader topic. So something happened in object detections. Along with this, something else also happened. So in object detection task, you are not only providing the image. Along with the image, you have to draw one bounding box around the object and pass that information also to the object. Are you getting what I'm saying here? Not only the image, but also a coordinates, 4-point coordinates you are passing to the model, which will help the model to identify which object you are referring. Are you getting what I said just now?
Okay. So in this centralization only we are doing this? Or that is the next step, like the masking that you say, that is the next step, or it is in centralization only?
Okay. So for object detection, let me explain what happens. So actually, this is a deeper deep learning related knowledge. So you have an annotator in your team, annotator. So annotator is a role inside your team, which if you're running a CV business, you have to have an annotator, but these days annotator is also not required because of AI. Now annotator's job is to draw a rectangle around the object. And that rectangle is the information about the coordinates. Okay, x coordinates of this point and x coordinates or x and y coordinates of this point. So while trailing, along with this image, you centralize this thing so that your pixel value range will differ or reduce. And along with the centralized picture, you are going to pass this is called bounding boxes, bounding box information. Now, based on the picture and the bounding box information, model going to learn, okay, this is a picture, and in this location there is a horse. Making sense?
Yeah, I'm understanding both the processes that you're saying, that there are two things happening. One is we are centralizing, and the other thing is we are like given where what is the location where I will find the horse inside that picture.
Correct.
But like when I'm doing the centralizing thing, like I'm changing the intensity, the mean of each and every pixel in my image.
Okay.
In that process, nowhere I'm mentioning, okay, you have to centralize this whole picture, but my main object is placed at these coordinates and you have to like.
No, that information you are not going to get here. That information, once you understand the model, there you have to mention.
Okay.
So not here, not here. Okay. Again, this is like I can. This is broader topic. So you need 1 or week 2 time to learn these things. So how this work? To the model, you will pass only this centralized picture. That's all.
Okay.
And along with that, you have to pass another value, that is the coordinate value.
Got it.
Okay, that is specific to the model that you can.
Okay, these are two different things, but done together to complete one task.
Correct.
Okay.
But that you will understand in a proper way once you understand the model structure. Okay, deep learning model. There is the option that you have to pass the coordinates also along with the image, and that time you have to pass the coordinates. Not okay, if you guys are thinking like I have to draw a rectangle then pass it, no, it is not like that. You have to pass the original image, then separately you just give the coordinates. That's all. We are going to do that. Okay, we are going to use the coordinates and mask this horse face. We're going to do that. Okay, let me go to that part. Then
so with the centralized pixel value, like we were centralizing the color values, like we were not centralizing any images or object in the picture.
Yes, that every pixel value we're centralizing, isn't it? Like every pixel
okay,
value.
So we were centralizing the pixels, like not the objects in the pictures and all.
Correct.
Okay.
And the next one is standardization. Now standardization, what is standardization? Minus mu divided by sigma, isn't it? So the distribution of pixel values are often follows a normal or Gaussian distribution, example bell-shaped curve. As such, there may be benefit in transforming the distribution of pixel values to be standard Gaussian, that is both centering the pixel values on 0 and normalizing the values by standard deviation. So by doing standardization, what you are doing? Centering as well as the range between 0 to 1. And how we do normalization, and after normalization how it looks like, let me show you. This is the mean and standard deviation before. Okay, after doing the normalization, that means here I did the normalization, guys. Okay, pixel minus mu divided by standard deviation. Okay, now can you see where is the mean and where is the standard deviation? This is standard normal, right? Mean is 0, standard deviation is 1. What is that? Standard normal. We saw this, right? And if we'll draw this picture now, okay, this line. This is how it looks like after standardization. But guys, let me tell you this thing again. This is not for us. This is for the machine to understand. We are just visualizing what is happening to our image in the background. That's all we're doing. So now if you see here, most of the part is now black, isn't it? And only the horse part is brighter. Now this type of things, standardizations, this commonly used in statistical analysis, machine learning algorithms that rely on input scaling on or when comparing images with different statistical properties. Okay, So to summarize these things, normalization is used to when the relative values or proportion of pixels intensity matter. Centralization is used to remove the overall brightness or variations. Standardization is used to preserve statistical properties or when comparing images with different characteristics. Okay, but I personally use normalizations because more of all, you can see we are just reducing the pixel values, right, to certain range. That's all what we are doing. But which procedure is effective? To know this, you have to do the experimentation on your own data, whether by following normalization or centralization or standardizations, which technique is giving you more accuracy. This is also one research part, because it varies from data to data, right? Whether normalization will give me the required thing or standardization or centralization, that will vary from the data you have, right? Suppose you have consider a picture inside the water where small fishes are there. Now small fishes are your object. Those part will be very less, right? So in that case, whether normalization will work or centralization or standardization, which will work there? That depends, right? You have to see that. You have to see in those small, that is called some small object detections. Okay. This is also one important project that I was doing, recognizing from the crowd. Okay. This is a very hectic and complex task. So there, whether my normalization will work, centralization will work, or standardization works, I don't know. Because every pixel is now one human, if it is a crowd picture, isn't it? So if I'll do something, or if we'll follow any of this scaling procedure, other objects may be blurred or something. So in that case, what I need to do? I need to check whether, consider few images and check which one is giving good result, whether normalization, centralization, standardization. But I usually follow normalization, and this also gives me better result every time. Okay, guys. Now here one concept is called masking. What is the time? Okay, we have 10 minutes left. Let me cover this one, because this is you are going to enjoy this one. Here masking means what? Now suppose, consider you have to detect, you have been provided certain images. Your task is to detect the face of horse, and in that image, cow's face also there, other animals' faces are also there. Then what to do? How? So you have been provided the training image. Okay, every image contains different animals' face. How to detect horse face from here? Can you think of something? What is the logic you need to apply so that you can identify only the horse face from other animals' face? You have been given 100 training images, every image containing multiple animal faces, but you just want to identify horse face. That is your objective.
Remove the background information and just focus on the
horse face. So while training, so think like this way, guys. The 100 images that is I am going to use for training, each of the 100 image, I will make everything black, only the horse face will be white. So in that way, the model will only learn the horse face among all the faces, isn't it?
Yes. So what I was saying is like we'll black out all the part of the image. Only the horse face will be visible to the system.
And this is not for us. While training, we'll do it internally. That means one image will go to the model. The model will automatically mask everything out as per the logic we have written. Only the horse part will be visible. Okay. So let's see how to do it. And also guys, if you are using OpenCV, then in Google Colab you won't be able to use the OpenCV to show the image. So for in Google Colab to show the image, if you are using OpenCV, this is the library. Okay, from google.colab.patches import CV to IMSO. Okay, let me show you through Google Colab. This is my hotspot. Okay, now let's do one thing. Let's do the masking. Let's cover everything else and only horse face will be visible. Making sense? Let's do that part. Now, what is this one? Okay, this one I wrote to make you understand. Now, see guys, this is how we are going to do this masking. Okay, this is called masking. So first we are reading the image. Second, we are creating a mask image. Now, what is this result will give me? This part I've written here, numpy.zeros image.shape.to. What is this one? .shape. If I'm accessing this one, what I'll access? Let me run this one. The first two dimensions I'm accessing, right? The rows and columns, not the third dimension. That's the channel information. So what does this mean? This means what? I am creating the same size matrix, but every value is 0. So tell me, if I want to plot this in an image, what is the picture will look like?
All black.
All black, right? That's correct. So this means I am creating a mask. See how we are creating a mask here by creating 0 with the same dimension of the picture, 600 and 960. Okay, but all values are 0. This is my mask data. Okay, next thing. This is the mask data. Here I am defining one coordinate. I'll tell you how you need to find the coordinate. You can do an hit and trial method to find the coordinate.
Ashish, sorry to interrupt you. So here we have used mask np.zeros and then image shape :2, right? So we know that that shape thing will give us the shape of the image. Like our image is like 600 width and then the 900 height. So how come this zeros will create it? Because image dot, like we have even we haven't created any variables or anything. So how come this will know that, okay, it has this much of matrix values and all those?
Because we are providing here, right? Image.shape, and then rows and column information. So this means what? Okay. Create a matrix with zeros, with this is the dimension, and this is the data type. No, Dinesh, what is confusing you here? Which point?
Yeah, like I'm getting confused where that shape :2 you have given, right? But in about to that, like the matrix created has a 3 cross. Yeah.
So see,
There.
okay. Let me show you. See, what is image.shape is giving to you? 600, 960, and the channel information?
3.
We are just excluding this 3 part. How to access?
Okay.
The first 2 dimensions. That's why we're giving 2, right?
Okay.
That means only the rows, and because we are creating a mask image, 2D mask image. We don't need the 3D data, right?
Okay.
So 2D mask we are creating same as the image 2D data. And what is this XYWH? This is the coordinates of the horse face. Now there is a question of how did I found these coordinates? To be honest with you, I like to make you guys understand, I started with a random number. Then I saw that in the image where that point is or where that boundary is getting, according to that I adjusted. But in real life, you need not to find these coordinates manually. As I told you, the annotator, right? So lots of annotation tools are there, where what we are going to do, you have an image, and that using that tool, you have to draw a rectangle around the horse face. That's all. And once you do that, a number with coordinates will be generated for that particular picture and will be saved in your system. So how to get the exact coordinates of horse face, that is not manually need to do. Is it making sense? But to make you understand, manually I try to find out this coordinates. Now what is this coordinate? X-axis, Y-axis, width. So this is a coordinate of what? A rectangle. The coordinates of a rectangle, where X coordinate, Y coordinate is the, okay, let me, so this is nothing but, just a minute guys, this coordinate is nothing but, sorry, this coordinate is nothing but X and Y is here. This is your what? Width. This is your height. You will find this coordinate. What is the coordinate of this one? If XY is the coordinate of this point, if this box is having width W, height H, what is the coordinate of this point? Guys, what is the coordinate of this point? X plus W, comma Y plus H, isn't it? Making sense or not? Am I audible? Hello?
Yes, sir. Yes, sir.
Okay, okay. I thought I got disconnected. See,
no,
guys,
not understanding.
you are not getting it?
I think
Yes, yes.
Ashish, in the image you have showed, it's the y minus h, I think.
No. Forget about the image. Answer.
Okay.
Think about this one. Okay, this normal example. This is a rectangle where this point coordinate is x comma y. This part is clear, right?
Yes, sir.
X y coordinate. So suppose this is my x axis and y axis. This point has some x and y coordinate. This is x comma y. If this box has width w and height h, what is the coordinate of this point? So if this value is x and this length is w, what is this value? X plus w, right?
Yes.
If this value is h y coordinate and this is height length, what is the y coordinate of this point?
Y
If
minus h.
Not y, correct. So y is this one, y minus h, right? Just to make you understand how to find out the points in the rectangle. So tell me, y minus h, why we did it? Because this is y, this is h, so this point is y minus h. Are you getting it or not?
Ashish, it's confusing for me.
Okay. Let me draw it again. Okay, let's not go with that y minus h and x minus h. This is a rectangle. Okay, the width is w, height is h.
H, okay.
Think like this one. Which
Ashish,
one?
take left side bottom corner. Yeah, that point.
This point. Okay, x and y. This is x and y. Now,
True.
what is this point? What is the coordinate of this point? If this is x, okay, what is this distance? W.
Yeah.
Then x coordinate of this point is x plus w.
Okay. Mm-hmm.
This point's y coordinates is y. That means this is y value. Okay, this is y value. This distance is h. Then what is the y coordinate here or here?
Y minus
See,
h.
y
Plus.
coordinate
Okay.
is here. This is y. This is another y coordinate. This is one y coordinate. This is another y coordinate. Here, this is y. The distance is h. What is the y coordinate here?
Y plus h.
This distance is your y. This point I'm talking about. This distance is your y. Agree? Everyone agree with this distance is y for this point? Guys, this point is y. Okay, this value is y, right? Then h top of it. What is the y value here?
Y plus h.
The same thing I'm writing here. So this point coordinate is what? X plus w and y plus h, isn't it?
Yes, sir.
Think, don't be in hurry, think it, because this is what you need to understand if you are going to deal with this kind of stuff in deep learning. So by getting one point and width and height, you will get the top, left bottom point and right top point. So if I have these these 2 points, can I draw a rectangle? That is the ultimate aim here. So now we have 2 points. Can I draw the rectangle? So this is what we are doing here. To draw the rectangle through the horse face, we are calculating the x coordinate. So this xy is the bottom left point. And width and height is the length and width of the rectangle. So the right top coordinate will be x plus w, y plus h. So this is my 2 point of the rectangle. One is xy, one is x plus w and y plus h. This is the 2 points of my rectangle. Which 2 points? Bottom left and top right. Let me know if you didn't understand. We'll make you understand again.
Yeah, now got it, sir.
Okay, just give me 2 minutes, guys. I know you are getting late for the office. Just give me 2 minutes, or else we have to discuss this tomorrow again. But just give me 2 minutes. See, once I define this point, I can draw a rectangle on my mask image. Mask image means that black image. So let's see this. If I just 1 minute, guys, instead of result, if I plot mask, what will happen? See, this is the black mask image we created, and here we are drawing a white rectangle by calling cv2.rectangle. Okay, so where we are drawing this, guys? On the mask image. And how we are going to draw? By giving the 2 points. What? Bottom left and top right. And this is the color of the rectangle. 255, 255, 255 means what?
White color.
And -1 means the thickness of this rectangle. That means I want to, like, if we'll change it to 1, what will happen? Can you see? If you'll give 1, what is happening? Just a, just a line of white line across it. But I don't need it. I just want to get total white in that whole area. That's why -1. -1 means fill that with all the area with white color. And that is the purpose that I'm doing everything is white. Because can you see now? this part is the horse face that I am making white, and everything else is black. Did you understand how we draw the rectangle here using the coordinates and the mask image we created?
And the values we have give x comma y comma, and that the values I know now, x comma y, x plus w, and y plus h. That we have given the here 3 values only. That x comma y is the point 255, and this is 255 is for x plus w, and another one is for y plus h. Is it right?
Yeah. So this is the in the rectangle. So what rectangle we draw here? This xy means this point. Okay. The rectangle's bottom left. X plus w, y plus h is the rectangle's top right. This information we are given. So that means we are saying take this black mask image and draw a rectangle with these coordinates. What coordinates? Bottom left point and top right point. And which color I want? White color. 255, 255, 255. That means white color. Okay. And how we want? I want full apply of white color inside my rectangle, not a thick line or something. Now, once you did it, you have to go for apply mask to the image. Here CV to bitwise image, CV to bitwise and. Okay, this is a function which will take 3 parameters. One is the background image, one is the foreground image, and what is the masking concept here. Now this part you will understand if you'll spend some time here. So this image, okay, let me show you. Guys, I will explain these topics again tomorrow. Don't worry. Okay, if you are getting late, you can leave. Okay, I will explain this again. Not a problem. So let me try to explain today. I'll explain this tomorrow again. Okay. See guys, 2 pictures are there. What we are doing, this is the background image, this is the foreground image. What we are doing, we are combining these 2 pictures and forming one new picture. That's what we are doing with bitwise and operation. Did you understand? Here I took 2 parameters, image. That means one is background, one is foreground. And what I am taking as the foreground background, the same image. Why am I applying the same image? And here mask means this image. So that means we are telling that use CV2 bitwise and operation. Take this image with a conditions of masking image and create me a new image. Now how this image will be created? Now what is bitwise and? What is, if I'll perform this task, what will be 1 0 if I'll bitwise and?
0 bitwise and 0
here
1
here
1. Sorry, 0 0 0. Okay.
That means if my binary data is all 1, then bitwise and is performing 1 or giving me 1. Rest everything it is giving me 0. Agree? This logic is clear?
Yes.
Now,
so the one image is a background, one image is foreground, and one image is masking, right? So where we get this background and foreground images? Like we only have one horse image, right?
Now we are taking same two images as background and foreground.
Okay.
But this is the condition.
Okay.
So that means we are telling join these 2 pictures, whether it is same or different. We are passing same image, but you can also, if you want to create a new kind of image, you can change this one.
Okay.
But here in this case, as per our requirement, we just want to showcase the horse face. That's all. Everything else will make it black. That is our aim.
Okay.
So for that, we are taking same picture twice, but with a conditions. What conditions? This is the conditions
Mask.
where
Yeah.
everything is black, only this part will be white. That means everything is 0, only this part is 1. So combine this two image where everything consider while combining everything is 0, only this part is white of both the picture. Of both the picture, if I'll combine, only this position, this white position is 1, rest everything is black. As per the bitwise and condition, what we observe, if both the picture 1 1 is there, it will be 1, rest every case it will perform 0 while combining the same image, but with masking conditions, where at this particular positions you consider these two images as 1, other cases make it as 0. That's why bitwise and. That means what we are doing, everything else we are making 0, only this part which is white is only 1.
So at the time, like as you said, like we were using, in this case, we were using a same image. So but instead of using a same image, we were using like one horse image and then the one dog image. So in the background, I'm facing the horse, and then in the foreground, I'm facing the dog image. So that time, these two images will be overlapped, right? So at that time, if I'm giving a rectangle, then the image will be very much collapsed with the background and foreground, right?
Correct. So what you just said, that you can do if your requirement is different, that you want to create new images based on your existing images. Good point. Suppose you have 100 images,
Mm-hmm.
now you want to create new images, you can use this concept and create 100 more images with different backgrounds, foregrounds.
No, no,
But particular,
like I'm not asking that, Ashish. Like I'm saying, like in this case, we were like giving the coordinates, and then we were drawing in rectangle so that we can take the horse image, right? So what if there is a horse and dog image in this case? So that time, however, the machine
Mhm.
gonna get confused, right? Because like even because we can see a dog image in the background, there is a horse image, and then in the
Mhm.
foreground there is a dog image. So how come the machine will process that?
Process. So suppose this is your dog image, this is
Uh-huh.
your horse image,
Okay.
and in the mask you want to see which part you want to visualize and which part you want to cover in the mask image.
Let's assume a horse itself.
Okay, so here is a dog, I'm not drawing properly, here is
Mm-hmm.
horse.
Sure, sure. Okay.
The mask image, you are saying this portion only will need to be visible.
Yeah.
So you, in the mask image, you make white that person and pass.
Okay, so at the time, this another image, like we were passing two images, right? So on that
Huh.
time, the two images, like one image was not useful at all, right? So we were not using it anywhere.
Yeah, and more of all,
Mm-hmm.
it depends on this condition actually, which part you want to mask, which part you want to visualize. That is also important part. Dog and horse part is fine, but
Mm-hmm.
after combining, which part you want to visualize and which part you don't want to visualize, that is also one requirement, right? What is, tell me what is the end picture that you want to visualize? There is your answer lies of your question. I want a picture with this and this.
Okay. Okay. So I just want to visualize the picture with a horse image in it. I don't
Horse.
want. Yeah.
Okay, so you create a mask image
Mm-hmm.
where only horse face will be visible, like we did here.
Okay. Okay.
Everything else will be black.
Mm-hmm. Okay.
Then
So that time, like if I'm giving a horse and dog in the same like in a same image. So that time also my system, I mean my module will say that okay, there is a horse found in this picture, but I'm blacking out the dog in that, so that
Dog face.
I'll get the result of a horse.
Right. So, but I know that you are not still 100% or not even 50% clear. I can know that. Okay. I know this. But to understand this one, no, you play with it. You download one different picture, then you download another different picture, create a mask image as per your requirement. Suppose you want to visualize only horse face, right? So try to find the coordinate of the horse face and create the mask and perform with the different picture. In that way you will understand more out of it.
Okay,
By
let me
discussing here it will be confusing.
let me do it. Let me, yeah.
Okay, do that. Okay, do that and
Sure,
let
sure,
me
sure.
know tomorrow.
Sure.
So guys, I'll explain this thing tomorrow again. But if you see here what is happening here, let's visualize the result. What is the result of this one? Can you see?
Yes.
So now we blacked out everything. Only the part where it was white is visible. Now suppose in if you used another picture, what will happen? Suppose you use another picture in the second condition, what will happen? The same thing where we just instead of this image, same image, you used another image of different background or different color. What will happen?
What's your question, Ashish?
So I use the same picture, right? Image and
Okay.
image here.
Mm-hmm.
Suppose you use another image here. In the second image, use another image where this is also a different picture with different background, different color. What will be the result here?
Excuse me, sir. We have used background picture and foreground picture. We may use only one picture. With this help of one picture, we can mask these other places, and we have focused on the white space. And for what purpose we are doing another image and foreground image we have created.
For to create a single picture utilizing two pictures for that purpose. So
Okay,
what I mean,
understood. Why do we utilize two pictures? That's what I'm asking. With
so
the help of one image, we can do this.
no, we will be able to do this with one picture. If you are using bitwise and you have to give two pictures. But there is other ways also around here that using one picture you can mask out, but that is a tedious task. So if you are using
for using bitwise, we have to give two pictures, and then we will get the result as one. That place will only be shown the faces or white space. It will show the image.
Correct. Right, Divya. So to know more about it, what is this? Where is the official documentation? See, if you'll go to the official documentation, you will find more detailed information about this one. What is happening? I'm not able to scroll. See, here bitwise and something is happening to my mouse actually. Oh, okay, sorry. You see here, they are just merging two image of the logo and this one, Messi's picture. Okay, and if you see here, if you'll go through this example, you will get a deeper understanding here, how they are doing it. Okay, and if you see here, bitwise and it is taking same to image and the masking conditions. Okay, and once this masking condition is done, they are just adding two images and creating the new final images with merging of two, this logo and this image. A very good example to understand the CV to bitwise AND. Okay, I'm pasting this into the chat. Okay, if you have time today, please go through it. Okay, because tomorrow again we'll discuss this one. It's 11:20, guys. I also have some
Sure.
work.
Excuse me, only one doubt, sir, about the project. We have yesterday I have gone through that we're using API, YouTube API have created key and have generated a YouTube channel's ID, some other name, views, subscribers, somewhat. My question is, we are while after getting these details, we have convert these details into MongoDB. After that, we'll create the table using of that. Then we are display in the Streamlit. We can directly create the SQL tables with the use of this uh, that JSON details that what they give. With the help of that details, we can create the tables. Why do we need to create the MongoDB, put it in the MongoDB? After that, we have to collect it into SQL. After that, we need to display that.
No, that is just to make you practice.
Yeah. So
like,
Ashish, and also I can see that like this project stuffs were already been done in some YouTube channels and all those. Like, is it okay to go through that and then to implement our knowledge in it?
Yeah, that's fine, right? That's fine. But the thing is, if someone will ask you what you have done, you have to explain it.
Okay, because like it's our first project, right? To be frank, I would say like I don't have any idea about my project. Yesterday I've gone through some Streamlit stuffs and then the API things and all those like Google I have gone through the YouTube API and then the Streamlit. For this only I got a time, and then I told you, right, this bankruptcy things were killing my mind.
No, that is
So
fine, Dinesh. You can
okay.
refer as many as YouTube videos or code snippets, everything. But the only thing is, while submitting, if someone will ask you what is this line, why you have written this line, you have to explain it. That's all.
Okay, so at last my project has to work, and then I need to give a video by explaining
Explaining
all
the
this,
code,
right?
correct. It will be a good that, because that will show you that you have the understanding while doing the project, because this project is everywhere. You can copy anyone's code and you can run that. By explaining it in video, you are showing that you understood it and you implement in your own on your own.
Okay, so we don't need any paper presentation on all this. Like, we only need the video to be explained.
Videos will be fine, I think. Like, that's also time saving thing, right? Because paper presentation, no one is going to read. If if it is a recruitment partner, videos will be helpful for them to understand rather than going through the documentation.
Sure. And also, I think on today there is a project and project related session. So let me join there and then have a more insight about it also.
Please guys, please do join that. And I think, Divya, you got the answer, right? It is like just to make you practice with both the SQL.
One more thing, sir. I have retrieved the channel ID and other views, subscribers, or somewhat others. With that, what we have created using MongoDB before, in the same way, we have to create the collection for the details for every playlist or somewhat other things. We have to create another collection. Is it the same way we have to do?
Yes, same way, but bit change. Here you are not going to use the MongoDB install inside your system. Here you are going to use MongoDB install in the cloud. That is MongoDB Atlas.
Okay.
So have you got the chance to explore this YouTube API and MongoDB stuff?
Yeah, YouTube API I have seen and have practiced that. Through that only have downloaded. I have extract the details of YouTube channels and details about the channels. But I don't have time to work in the MongoDB at last. I have not seen anything about that.
Do it. Like that's fine. Just explore the MongoDB Atlas part. How to use MongoDB Atlas? That's all you search in YouTube. You'll get it.
Okay. Actually, today I have did only that API part. I have used that API key. I have retrieved the YouTube channels details. That's it. I have did till now. After that, after collecting all the details, playlist details I have not yet collected. After that, what I have to do?
So that is fine. So what have you have done, that is totally fine, and I'm really happy with that. So first
Yeah.
of all, congratulate yourself that you did the YouTube part. Okay, so first you do that.
Oh, thank you, sir.
Okay,
But
that
I'm not very much clear. I'm just having the view where we have to do in actually in that based on the data I have created the collection using MongoDB. Apart from that, what I have to do, I'm not clear in that way.
So did you go through that Streamlit app creation?
Have just not fully just have seen that like dash we have plotly what we have created the plotly with the same like that we can able to create. That's a thing only have
So
gone through
okay,
that.
Divya, one thing you do. Okay, let me make your task easier for you. Forget about the MongoDB Atlas as of now.
Okay.
Go, so you now you can retrieve the YouTube API details, right? Go through the
Yes.
Streamlit documentation, create one application through Streamlit, which will retrieve the, so here what you need to do, you need to create an application in Streamlit where user will input the YouTube ID, okay, YouTube channel ID, and hit a submit button.
And yeah.
Okay,
And now I
and
understood. In that project, they have told only 10 YouTube channels you have to create this and other details about that only for the 10 YouTube channels. Do I have to create it for that in YouTube? I have seen one video that was particular about this project. In that they have the data manipulation and MongoDB SQL, and then they have the tab for presentation. While clicking that, while clicking the data, it shows the all the channel ID. After getting the channel ID, it goes to the MongoDB. It will store the data YouTube channel ID. While giving that ID in MongoDB, it's stored in the database, MongoDB database. After that, actually I have seen the video like the way. Is that right? Or I don't know how to do that.
That is right. That is right. See how
But,
to do it. It is not coming to you one day or 2 days. Okay, you have to spend some time with it. So you
okay.
don't go for the last part. You just focus on the first part.
Okay.
Yeah,
So,
as I said, like there is a lots of videos, and then I think
uh,
for Google API, and then for Streamlit itself, like for installing the Streamlit itself, I have gone through 10 videos, like
so
2 minutes,
see,
3 minutes,
see,
10 minutes videos.
test this task for you as for these 2 days. Test this task like create a Streamlit app where you will enter one YouTube ID and it will show in the screen itself. It will show you the counts and likes. That's all. Do this much only. Don't go for the
Okay,
MongoDB
sir.
now.
Okay, I'll try, sir.
So
One by
just
one. Okay, one by one I'll do. First I'll do these things, and then I will do others.
so did you get what I'm saying? Like what you need to do?
Yes, getting the what I have extract the details of channel IDs with the help of that channel IDs. I have to in Streamlight that we have to create the buttons or somewhat other things. Have to show the channel IDs. What are the channel is there, and what are the views and some other things I have to shown in the Streamlight.
Correct, correct. So that means in the UI, you have option to input the channel ID. Okay, there is the submit button. Once you hit the submit button in your screen, all the videos, the likes count, everything will pop up.
Okay,
that is the
if
only
I
thing.
gone through the Streamlight videos and get the knowledge about that, I can do that, right?
Correct, correct. So do this first, okay? This one, once you complete this, one milestone achieved, okay? Then you go for next milestone.
Okay, I'll try, sir. Today I'll try.
Sure. Let me know, guys, okay?
Yeah, sure. Thank you.
Yeah, just thank you.
Okay, guys, okay. Then see you tomorrow. Have a nice day. Bye.
You too.
Yeah, sure, sir. Thank you.